Okay, so we're going to talk about computer vision APIs today, and I'm gonna just whiteboard a couple of things here that are important to discuss. So one of the things that's interesting about computer vision is this concept of what abstraction to use. So we'll say computer vision API. And you could think of it as complexity would be low. And we'll just say this is complexity. And then high. And if we go through here, and this, if we just assume that this is a choice that we're making when we're making a model, you could say that the API would be probably lower complexity, and then TensorFlow, for example, could be a higher complexity. And then I guess the question is do you need it, right? Do you need the high complexity, or are you okay with getting away with a lower complexity? And so what are some of the problems maybe like with that you can solve with either one? So if we look at an API, what an API seems to do pretty well is actually create labels. And this is where I see people using the computer vision API would be that you could actually, let's say you have 1,000 images in a bucket somewhere, and this is on Amazon S3. You can easily label all those, so you can just run maybe make a function here that's a lambda function. And that could listen to or process all of those items, create a label, it could be dog, cat, bird. And then once it finds those labels, it could put that into a database somewhere. Like it could put that into a DynamoDB database. And that could be actually a command line tool. So this could just be we could create a tool called labels, for example, .py, and that's what it would do is just go through. You give it, let's say, a bucket, and then it would process everything inside. It would be, let's say, -- bucket, for example, and it could process everything inside of there. So depending on what kind of problem you're solving, that might be a great tool to start with, is see if you can create the labels for images, and later you could also take those labels and use them in another computer vision model. Now if we look at something that's more high level complexity, you could, for example, let's say you wanted to train something to recognize a road, for example. You wanted to, build a self-driving car or something like that. Well, in that case, then maybe you do need to, we'll call this a car. You do need to use a lower level tool, like something that can handle reinforcement learning, and you would need to go into TensorFlow, and you could build out something that specifically had a reward function, and the reward function would be something you would train, and you would go through and change the parameter. So, and I'm not saying this is every situation. This would be the trade-off, but it's just something to think about when you're building a computer vision API. Is, does the low-level tool already solve the problem? And if it does, maybe that's a good start. But there are other issues that come up in computer vision, and so let's talk about those and how they relate to an API. And one of them is pre-processing. So let's just call this a computer vision pipeline. And these problems actually happen regardless of the complexity you're using. Is you would have step one, for example, you would have the actual images, the raw images. And one of the problems that's very common is that the images maybe, what are some of the things that could happen? They could be too large, right? That could be one problem. They could be damaged. That could be another problem. Like maybe the images are from, a historical period where they didn't have good resolution. Maybe they're the wrong resolution. Another issue could be they could be a different format. So maybe the images are in a format that needs to be modified. Also, maybe you have a low amount of images. So you maybe you have only 50, for example, and you want to get more. So this is not an exhaustive list. This is just some of the common, we'll just call this common problems. So how can you address this? A few ways that people are addressing these is you create some automation tools. So what I would do is next up create tools, and so the tools could help address some of these issues. So maybe one of the tools could go through and it could resize things, right? So and in fact there's some really good tools around this that have been used extensively in the film industry, which is my background, and Image Magic is one of them. Image Magic, I think it's something weird like K or something like that. It's not proper spelling. There's also next generation tools. So there's actually, let me put one other problem that happens with images that's very common is duplicates, right? You see this. In fact, I wrote in my career several commercial packages actually that dealt with duplicates. I had a whole company around this at one point. That's how big of a problem it is. And so you could have another tool that maybe finds duplicate files. And the duplicate files, you don't want to have the same image twice. So maybe you want to find those and delete it because it's going to take up extra processing space. Another thing you could do is you could do augmentation. So if we go to augmentation, one of the things that is built into Keras is Keras has, which is built on top of TensorFlow, it has data augmentation tools, and so it could make new images, right? So this could deal with the issues of having a low amount of images. So, and again, this is not an exhaustive list of how to solve all of them, but in general, this is the idea, is that it's naive to think that just because you're using even an API or a pre-trained model that everything will be good at the beginning. It's important to think about the tool chain of how you would build something. So let's go to another step here. And this is very similar. This mindset is something very similar to a world that I spent years in, which is film pipelines. So let's talk about a film pipeline versus a computer vision pipeline, which you could call them actually the same thing. Film pipeline versus computer vision. So if you are building computer vision pipelines, you'd probably be pretty good at building film pipelines. And in a film pipeline, what happens is that they have images that are generated, and they live on a giant file system. And that file system is able to take images, put them into some kind of processing pipeline, and they could, let's say, transform them. They could render them. But in general, the concept is that you ingest the data, you process the data, and then you create the solution. So that's basically the concept in a film studio, is that you ingest this data, you do these operations to it, and then you come up with a solution. Now in film, the solution would be a movie, right? You would go through and you'd create a movie. But I think many people aren't aware that film is just a bunch of files. It's a bunch of files on disk. You do these operations to it. Same goes with computer vision. In a computer vision pipeline, let's say you want to build something that detects cancer in X-rays. So let's go through that process. How would you do this? Well, step one would be that you would ingest the data, and then step two you would need to do some kind of pre-processing step, and it could be substantial, in fact. And it could be substantial because of the fact that you would need to resize things. You would potentially need to do data augmentation, etc. And then finally, you would train the model. And then in step 4, you would then do prediction. But I think the key takeaway here in building these kind of things is to think about that it's essentially a feedback loop that never ends. Is you're always, stuff comes in to the feedback loop, it gets processed, and then it comes out, and that's with film, with computer vision, the same thing. It's not like a batch process that it stops and you do it once. It's constantly running like water, and that's why they call it a pipeline. Is that these are kind of going back and forth. So what we're going to do is we're going to build a solution using the AWS API from scratch, and let's draw what that is going to look like. So how would you use the AWS ecosystem to build computer vision tools using their APIs? So let's draw that out. AWS computer vision APIs. And this workflow would also work with other things other than just computer vision APIs. But step 1 is we're going to launch a Cloud9 environment. And Cloud9 is great because it allows you to launch a development environment with an IDE that's inside of the cloud. And one of the advantages of it is it has special hooks to the cloud tools. Like, for example, it has a special hook to AWS Lambda. Here we go. Lambda. And in fact, inside of here, I can have a feedback loop that allows me to test and deploy my code. And so this is pretty helpful in that I can build, let's say, a trigger that could talk to, let's say, TRI. There you go, trigger that can talk to, let's say, a bucket. In this case, this would be an S3 bucket, and whenever I put items into the bucket, that will generate an event. So we'll say this is an event, and then that event in turn triggers this Lambda function, which would then do the labeling for me. So this is a really efficient and great feedback loop. And this is how I would typically build some kind of a computer vision API. And that's exactly what we're going to do. And I would even start, let's just say this is step 2. And then step 1 would be that I would build a command line tool. So a CLI interface. And first that would go through and do a label detection. And then once I'm able to do the label detection, then step 2 I would set up an automatic trigger. So this is a concept called serverless. And the reason why it's called serverless is that there are no EC2 instances that I spin up or manage. I can just focus on building logic, and by focusing on the logic, I can more easily build solutions by really just taking what's in my brain and putting it directly into code. So let's go ahead and let's build one of these things out. So let's go to EC2 here, or sorry, AWS, and I'm going to launch a Cloud9 environment. So I'm going to type in Cloud9. And the other thing that I didn't mention that's important to mention is that because this is in the cloud, the bandwidth that I get in the cloud environment is very high because they're all in the same data center, an API call. So first I'll make this a new name here. We'll call this Computer Vision API, and we'll say this is a Computer Vision API service. All right. And this is something to point out is that most of the time, if you're a student or you're just a hobbyist and you're playing around, that I would leave everything default, but I will clearly say a few of these things. So first, this is going to spawn a new EC2 instance for you. And this instance type here is a micro, so it's 1 gig of RAM and 1 CPU. Is actually plenty if you're going to build command line tools, and it's actually free tier eligible. Now, if you do need to do something that's very compute intensive, for example, you needed to use, let's say, 100 cores or something, you actually can get access to that. You can see that these have extremely large machines here, like 384 gigs of RAM, 96 CPU. So if you wanted to just quickly run some kind of a simulation that was massively parallel, this would actually be a great choice because you're only charged by the second. The first minute is fixed cost, and then it's a second after that. So I think this is a great environment for doing prototyping. But again, I just need the micro. Also, I would recommend Amazon Linux here. It's critical to use the type of operating system that's the default, in my opinion. Unless you're a true expert, then sure, go in and maybe use Ubuntu server. The other thing that I'll point out is that cost savings here, this is one of the nice features of this cloud-based environment is it'll automatically time out. As long as you don't have a process running or something, it'll just automatically time out. And so you also don't have to worry about accidentally leaving it running. So let's go ahead and say next step. And actually, one last thing I'll say is that because this is running as whatever role I'm linked to, I don't have to use API keys, which is actually a great security improvement. Okay, let's go through here and let's create an environment. After I'm done with this particular component, the next component would be that we would go through and is think about where this model has actually been created. So in in the example of the API, if we were able to kind of finish that process, do all of our labeling inside of here, the next step after the labels are completed would be to think about, is this good enough, right? So is this label actually good enough? And if so, then we could think about this as the pre-trained model. So this is the pre-trained model, or what we could do is actually train a new model, and the new model would have an exportable edge device. So yeah, let's since we were able to get to that, if I remember correctly from your question, is that we were able to go through some of this last time, correct? We were able to get to the end of building the command line tool. If I remember your question correctly, we went through creating this device. That's correct.
Yeah.
Yeah. So if we went to, okay, yeah. So then the next, we were able to do this one, right? S3 trigger lambda, I believe. Yeah. So if so basically, then the next question would be, and let me just draw this up, is in terms of an API versus a exportable edge device, what's the difference? So we have an API and we have an exportable edge device. And the API is actually just sitting with a model that is called, but an exportable edge device is also a model, but we're going to put that model onto a physical piece of hardware like this, like this. So they're effectively the same thing. The difference with the API is this is actually in the cloud and it's proprietary, but in this example, we can actually download it to our device. So let's go to a Google Cloud here real quick, and let me show you in terms of Google Cloud GCP console, how this would actually play out. So they have their own AutoML system, and notice again that they also differentiate between either the Vision API, which is their pre-trained model, which they own. You can't download their pre-Vision API, or you have the AutoML Vision model, and this is when you would classify it yourself and then download it. So if we click on this AutoML Vision API here, and we go to datasets, in this particular case, what I would do is I would upload this to the AutoML system, and then when I'm done training it, I would select this particular device, this particular setting, and actually go through and export it to a mobile device. And the key takeaway is that it's a TF Lite based package. And if we look, and some of the different options here would be that I could export it to just the raw TF Lite model. I could export it to JavaScript. I could export it to CoreML. I could export it to a container, or I could export it to one of these TPU devices here, which is this thing, this Coral TPU. And in particular, this is something that I'll show you that I think is one of the most interesting edge-based devices. Is if we go to prototyping here, and I go into the dev board here, and we go into the different types of edge-based devices we have. This USB accelerator is probably the better one to use for edge-based prediction. And in particular, what's nice about it is that it will work on any kind of a host operating system, from Debian Linux to OS 10 to Windows, and it also works with AutoML Vision. So this particular workflow is documented here, and you can see that the setup is first copy a set of images to Google Cloud Storage, create a CSV listing, use the AutoML prediction, and then export it. So if we go back to this real quick, again, this is the big comparison. Is the API, there are, as we mentioned and we covered before, there's a lot to like about it, but the one difference is that the cloud vendor owns it. Right? So I can't, on one hand, that could be an advantage because they're updating it frequently. But on the flip side, with the model that you train yourself using, let's say AutoML or another system, you actually own it. So in this case, you own it. And as they mentioned here, if we go back to this real quick, is that these are essentially the steps: is copy the file, create the CSV listing, do AutoML, and then export it. So the process here is slightly more complex in that you would have to say, we'll call this one. You'd have to say copy images, and then B, upload labels, and then C, train the model, and then D, export it. In this case, in the Cloud API example, if we're comparing the two examples here, is that you only need to upload and label. Upload and then label it. So what on one hand, they're competing solutions, but there's also potentially a complementary workflow as well. So one thing that Google Cloud actually talks about as a potential workflow is that you could use both. So let's say that you have so we'll call this a hybrid API plus edge model. How would you build something like this? Well, the way that you could build something like this is that you could have two pipelines. So this would be pipeline 1, and pipeline number 1. What we would do is go through here and put the images into a storage. So we'll just call this cloud storage, and then step 2 would be to label it. So this is step 1. Step 2 is label it. Label. And this would be the API. And then that would create a CSV file with these labels. Again, let's say that it's we'll call this a manufacturing company. Manufacturing company. in this case, now I actually have two things. Before I just had the images, but let's say that it detected a bunch of different things in there. Let's say it for the first row, it was a let's say it was a how about a car? How about it detects that it's a car in row 1, and it also says the color. It finds the color, and it also finds maybe like a dent or something, right? Like it found these 3 labels for us. But let's say that now I also have pipeline number 2, and what I do is I take those labels, do the same thing. I have the cloud storage as step 1, but in this case, I also annotate. So maybe I get some humans to come in here in my company or a service, and then I actually annotate the labels and I enhance it. So it turns out that this car was something my company produced, and so what I do for the first row here is I say car, blue, dent, and then I say Ford, because I'm the company that made it. So you would annotate and enhance that label, and then you go through and you would train it again. And now what's different here is that I used the pre-trained model here, this which was proprietary, that Google owns, but I was able to actually steal some of their smarts and put it into my own system, because those labels came from them. So I'm actually, you can leak the secrets essentially of their training system into your system, train it, and then now I have a model that I can export, and I own it, and I can put it onto a device. And I don't think this is necessarily stealing or anything. I'm more joking in that you're able to take the intelligence that they've got in their proprietary system, and you're able to now take it, train it, and then bring it down locally. So again, this is why this workflow is pretty interesting, is that if I go through here and I use this Coral hardware, I can then do that prediction directly on my machine. Now, what I'll show next here is that we can actually do a prediction with this particular device. And let's go through and let's look at this product real quick. And what I'll do actually is I'm going to share two screens at the same time so you can see this. So I'm going to open up a terminal here, and then I'm going to change the sharing so that you can see me work on 2 things at the same time. So I'm going to say share screen and go to portion of the screen. And then what I can do here is make this a little bit smaller potentially. Let's do this actually. Well, maybe that's good enough. It's but basically, and I'll put this over here. I don't know why this is so big. I'm trying to make this a little bit tinier, but it's not letting me drag it down. Let's see here. There you go. A little bit smaller. That's a lot better. And how about that? Perfect. That's pretty good. Okay, so what I'm going to do next here is let's actually run this thing locally. So again, I'm gonna take this device here and I'm gonna plug it into my computer. So I'll plug it in right here. And once it's plugged in, I can show you the step. If you are going to use a physical development kit Probably this one is the smoothest experience because of the deep integration that it has with the AutoML system. So let me go through here and now it's acting a little bit weird. Let's try this. Here we go. So what I'm going to do is run this get started with USB accelerator, and here we go. So first step, I'll need to install this Edge runtime on my machine, and it works with Linux, Mac, or Windows. So any computer you have should work fine. So the first thing that I would do would be go find the Mac version here, which here we go. Here's Mac. So I would just run this command. So we'll go through here, and I'll just run this. There we go. And then next, I would unzip this file. So we'll go through here, and we'll unzip this. And I'll go ahead and I think I had already created this, so I'll just say yes. We'll replace it. Let me just delete that other one and just do it again. Runtime. Download this and unzip it. There we go. Okay, so once I unzip it, then I'll cd into this edge time, runtime here, and then I'll run sudo bash install. Bash sudo bash install.sh. So this basically enables me to use the physical hardware, this TPU, this local TPU. So I'll go ahead and install this. And then when you first install this TPU device, there's two options. The first option is that you can make it run like more of a normal heat load, or there's one where you can do a maximum operating frequency where it actually is very, very hot. And in this case, I'm going to say I want it to run at the maximum speed because I want to get the best prediction power. And so I'll say yes. There we go. So then it goes through and it does this installation that it basically goes through and allows me to completely optimize my local machine for that hardware. So you can see here it's going through. It's installing libusb. Okay, great. So it looks like it's all installed. And then I'll just go through here and it says running at the maximum operating speed increases the inferencing speed, but also increases power consumption, and it can become very hot. All right, so then next what I'll do is install the TensorFlow Lite library. So this is a library that is specifically designed to work with a on-device edge device. And in particular, this TensorFlow Lite library, we would use pip3 to install it. And so how would we do this? Well, this is how we would do this is go to this TensorFlow Lite Python install guide here. And what I typically do when I'm installing something is I'll maybe put this into like a temp directory for now, like this, and then what I'll do is I'll create a virtual environment. So I'll say Python 3-m venv, and we'll call this tf lite. And the virtual environment, the reason I do this is so that I can isolate everything I'm installing to this one directory. So then I'll source it. In fact, yeah, source tf lite bin activate. There we go. And then once I've got this sourced, then I can do the actual install. So Here we go. I need to find my operating system. So it's going to be this one. It'll be Python 3.7 and this particular version. So I can just copy this, and then I can look at what the instructions say. It says pip install. So let's do that. Say pip 3 install, and then put in this particular file. So for you, it would just be whatever version of operating system you have, Linux, Windows, OS 10, whatever. Okay, next step, we'll go through here and we'll install this. All right, so it looks like that's ready to go. And then the way I would test it would be a couple different ways. If I type in IPython, let's see if that works. Import TF Lite. So it looks like I might want to install IPython. Let's see if I do pip3 install IPython. I like to use IPython because it's really easy to test things out in an interactive fashion. But I'm also going to go back to the instructions here, and it says you're now ready to run a model using TF Lite API. And in particular, I think they say this though in the instructions. Let me just look at the instructions here. Yeah, so they say you would do this to test it out. So let's go ahead and test this out first. If I type in IPython, I would do, and then I could just literally copy and paste this in. If this works, it may not work with IPython though. Let's see. Okay, it does work, but that's it. So basically it's very, very similar to regular TensorFlow, except for you import it like this, and then if you were going to then take your file that you got from the Google Cloud, right? Like if you were downloading this thing right here, this is this TF Lite file here, you would give it this path right there, right? That's all I have to do is give it that path, and then you're ready to go. So what I'm going to do next here is go to this last step. And what is this going to do? This is going to actually run a downloaded sample TensorFlow Lite API model. So how do we do this? So the step one would be to make these two directories. So make the directory and change into it. Next, this is a sample library that they've got that has a pre-trained model and some data inside of it. So it's kind of like a hello world TF Lite model. And we go inside of here, and we go into TF Lite, Python, examples, classification. There we go. And bash install requirements right there. So what this is going to do is that all is going to do is download the file and it's going to get the labels and get a bird photo. In fact, why don't we just look at that so you can see that it's not a magic script. If I just look at that file, it doesn't do a lot. All it does is it says make an images directory and download some test data, right? So it's mostly comments, right? So I'm going to run that script here. There we go. So we run this script. Okay, great. Now that we've got this thing running, it also lets us have this command line tool that takes just three options to this command line tool. So it would be Python 3 here, classify image like this. And if I run this, you can see that it shows me the different options that I can use. So what we'll do in this case is run. In fact, I can just copy this directly inside of here. But basically, this will go through and classify the image using the model, the TF Lite model, which again would be exactly the model you would get from the AutoML Vision API, we would use these labels that are included here and then do a prediction against this parrot. In fact, before I do this, we'll run it and then I'll show you what's inside the labels. So it was able to do a prediction of this. And so I could actually just open this file so you can see what it is. I'm going to say open images parrot. Let's just see what that is. And I'll bring it over here. So it's this. So I was able to find this parrot. And if we look at the labels here, we can just paste this out. This is able to cat this for us. There we go. So you can see that it knows about roughly 960 or so types of birds inside of here. So we could even look through and test this out. Like if we really want to give this more of a proof of concept, is find some other bird in here. Like I don't know, let's find some other kind of bird. How about a sooty tern? I don't know what that is, but I'll look it up here and we'll find this image. This sooty tern is a seabird. Okay, and there we go. We'll just download this picture. We'll say save image as, and I'll put it first on my desktop, and then what I'll do is let's see here. They have it in images, so I'm gonna CP from my desktop. That's that sooty. Where's this guy? It is here. This one. There we go. So I'll copy this one, and I will copy it to images. There we go. So now I've got this one inside, and I could just basically tweak this so that I can do this next image. So I just need to change it to be this one, like that. And what happens? So it was able to successfully detect what that bird is. So my opinion, pretty powerful, right? Is that I guess if I just sketch out a couple things here that we just did with this, is that let's talk about the edge-based models with in particular the TPUs. So the TPU ecosystem in some sense is one of the most interesting ones. So let's call this the TPU universe. The TPU universe. And it's interesting because it has small form factor here. So small form factor. And it could be anything from, and we'll just call this a TPU. So we know it could be like the device I just used, which is this USB device, which I think is worth having one of these if you're into edge-based computer vision. Let's boy, it's the Zoom sharing features got some issues. So just gotta click one more time in here. Yeah, Zoom when you're doing, here we go. So the small form factor would be, you could have one that's really the size of like a penny. These TPU chips, and we'll just say this is like a penny. You also have the USB type devices here, They also have boards. You have dev boards. And where can I get the TPU? So what goes into this? So the TF Lite model is the thing that it communicates with, and the TF Lite model can come either from Google AutoML, that's one input to it. You also could train it yourself with, let's say, Keras, and that could put the TF Lite model. Or the other one is they have transfer learning, or TF. We'll just call this TF Hub, TF Hub, and you can actually download a TF Lite model. So we'll just say TF Hub, and you can download a model. So you can AutoML, train it yourself, or just download a model, and then put this onto a device and do a prediction. And as I mentioned before, the AutoML, this is where the API story comes in, is that you could have put some of the smarts from the Google Vision API, they could have leaked inside of here. And so you can actually take that information as well. So the story for TPU, in my opinion, is probably the strongest edge-based story. And so the other thing that I'll briefly try to do real quick here, let me just move this down a little bit more, is let's see if we go to TF Hub here. So I'm going to go to TF Hub, and let's see if we can find another TF Hub, TensorFlow Hub. And let's see if we can find another TF Lite model, download it, and see if we can put that onto the device. So if we go to TF Hub here, we can look for different kinds of models. So if we go to model format type, I can find TF Lite. And I don't know actually which version. That's a good question here. Let's see. Does it tell us which version of the model this is running? I'm assuming that this would be TF Lite 2. That would be my guess. But for example, here's a collection of ML compatible TFL models. These are image, but let's just say we want to find this, and I could go through here and find a TF Lite model here, model format TF Lite, text embedding image. Here we go, disease classification. So if I crop disease classification, so if I click on this, let's see here. I believe I can just, I can go here, and here we go. Here's the model format. Here's the prediction. I could download this locally, disease classification. And if I open up another tab here, and I just go into my, go into downloads. I could go to this, or maybe it's on my desktop. Go to this disease classification model here, which is predict, unzip, disease classification. There we go. And you can see that it has, inside of here, the different assets. So if we go to assets, change into, anyway, I won't go through this because I haven't done it yet, but the concept is that you can go to TF Hub here, download it, and then put it onto your device and start to prototype out other models without having to train anything yourself. So I think that this story is a pretty powerful story for doing edge-based training. So if you have a chance, I would recommend this. Boy, it's irritating. It won't go a little bit wider here. Oh well, but this story is a pretty good story. So what I'm going to do next here is I'm going to close this window, and I'm going to make this a little bit bigger. And let's also talk about some edge-based devices here. So I think it's this one. No. Yeah, let's talk about this particular workflow. So in particular, why is it that the APIs interact well with edge-based machine learning? As we talked about, that they're low latency. There's the 5G system is a great target for edge-based machine learning, and that there's these specialized chips like a TPU. And the key industry players here are AWS, Google, Apple, and Intel. And what we'll cover this next week, but Intel, Movidius, and iOS Core ML are also solutions as well that will tie into this. So what I want to do next here is just walk you through how you could, if we go back to this diagram here, how we could actually build this, is how we could use AutoML to train our own system. We saw how easy it is to execute it and download it. We saw how the API itself is able to enhance the AutoML, but how would I actually go through and train the AutoML system myself? So let's go through there and do that. So I'm going to go to GCP console here, and there's a couple ways that I would recommend working with AutoML. The first one would be that you could actually follow a guide here and just go through and follow this particular guide, and it's a very good guide. And let me just talk you through these steps here real quick. So step one would be that you would have to enable your project in Google Cloud, enable the APIs, and this is more like just buttons you have to click, and then create cloud storage bucket, copy your images to the bucket, create a CSV file. And again, if you're using a sample project, you could just put the sample CSV file. But if you were going to augment it with the API labels that I was talking about earlier, this would be an important step, is which labels do you want to train it on? Just the labels that you've put in there yourself, or do you want to augment it with an existing AI API? Next up, you want to go ahead and create your data set. And I'll walk you through this in a second. And the options are, when you create your data set, are single label classification, multi-label classification, and objects. So if you were going to just train it to predict, for example, between cars and bikes and buses or something, you would do single label classification. But if you wanted to do the augmented example, where you had lots of labels that were created from the computer vision API first, then you would select multi-label classification. And then it'll go through and it'll build this interface for you. And again, at the very end, you would train the model, and it would tell you how many images you initially had, and whether it was going to be able to work. Once you train it, this is the really important step here to remember, is that you want to be able to select edge so that your device can be downloaded from the AutoML system. And you also want to select what kind of trade-off option. In particular, the trade-off option, it would be selecting whether you want to do predictions, the time it takes to do the inference versus the accuracy. And so it depends on what kind of a problem you're trying to solve. You start the training. Once you deploy the model again, it would be this. You would want to select export. And then what you would do is you would download this model. And also keep in mind here that I was showing you this particular example here, which we'll also get into a little bit next week. But this, I'm showing you how to do this. But you can also download it for iOS or for Android as well. So it will use the hardware for iOS or Android as well. And so if you pick this just regular TF Lite model, this will work well with Android. If you wanted to pick the physical hardware that I just showed you, it would be this one. Or another one that you could use is you could use CoreML, which we'll talk a little bit more about next week. But this would be a ability to run the model on iOS or Mac devices. So again, here's the final steps, and you get these are the three artifacts that are created: is model TF Lite, dict.txt, and then also TF Lite metadata .json. So let's go back to this interface here, and let me just walk you through step by step how this looks. So if we go to AutoML, Cloud, AutoML, Vision here, and we go to dashboard, you would upload the data set here. And let me just show you how that would work. If I click on new data set, it again gives me that same dialog box, right? I can just say, birds or something. And then I would select either single label, multi-label, or object. So I think the one you probably want, if you are not augmenting your data with a bunch of labels, is probably single label classification, unless you're trying to do something very ambitious, and then you could pick the multi-label classification. So then when you click create data set, what it will do next is it gives you one of two options: either upload the images from your computer or select a CSV file. This is probably the best way to do it. Is that, notice how it looks here, is that when you create the CSV file for the AutoML system, you need to give it the set. Is it a training data, right? And the training data, again, is the way you would create a model. Is it the test data? And that's how you validate whether your predictions are accurate. And then also give it the path to the image, like what's the full path to the image. And then also, what is the label? Is it a cat, a dog, happy, or whatever? And then really that's it. Once you upload those images, upload the data, then take the CSV file and you browse to it and you click on it, it will find it. Then that's all you need to do, and it will upload it. So I won't do this because it takes a long time, so I won't show you the exact process of how this occurs. But I will show you what it looks like once you've done it. Is that it will, if we go here, it will give you a whole interface to explore the data. So this is one of the advantages of an AutoML system, is that it basically is a full end-to-end solution that holds the data, it holds the model, and then also lets me look for things like we talked about earlier, like duplicate images, bad data. So for example, I think I know there's some bad data in here. Like if I went through the roses, I'm pretty sure there was some like data that doesn't even make sense inside of here, like this, like that's not a rose. Like so I could immediately go, oh, whoops, I have some bad data. I should go in and delete that before I train the model, so that I get the best accuracy, right? So that's the advantages of using a visual AutoML system like this that lets me inspect it. So once I've done that, and I click on train, it also will show me the prediction accuracy, right? So I can go through here and look at the precision, which this is the frequency of predictions that were correct. And so there's fewer false positives if you have high precision. And then recall is the fewer false negatives, right? And so we see that the precision is 98.1, and then the recall is 98.37. And I can actually look at a full evaluation here, and will give me things that you're probably used to. Let me make this a little bit smaller from regular data science, right? Like you can go through here and look at the difference between precision and recall, and look at the curve, and then you can also look at the confusion matrix. And so this would be where if you were going to label your own project, would be very important to inspect. This is where is it making mistakes, right? Is it, in this case, you can see that this roses, in the case of tulips, it misclassifies roses in tulips 4% of the time. So it's confusing. It's thinking that the tulips should be a rose when they're not, right? So it's incorrect. So if I go to tulips here, I can even visually look at the problems. So I can go through this and say, your model, here we go. Here's some of those. Here's some correct one. And look, in fact, I can actually look at all of them. I can literally look at all of them and see what the prediction accuracy is. And then I can look at the false negatives. So these were tulips, but it wasn't able to detect it. But then the worst ones are the false positives. And here we go. Look, these were incorrectly predicted as tulips here. And so this shouldn't be, this is, I believe, a rose. Yeah, this is a rose, and it shouldn't have predicted that it's a rose. So this is a very powerful system to prototype solutions. And if you're focused, that's what I like about AutoML, is that it helps you think more holistically about the pipeline. And as I mentioned before, the API and the pipeline work very well together in developing a solution. So how would you use this in your project? What I've seen students do successfully in this class is that I think it's important to think about how quickly can you get the feedback loop working, and so where are you spending your time? And so I think one way to think about this would be, if we go back here, is that if we look at building, we'll take AutoML advantages. So one of the reasons why AutoML can be pretty powerful is that you could focus on the business problem. So focus on business problem. That's probably one of the big takeaways of AutoML. And you can have a faster feedback loop. So what this means is that if you go through this feedback loop, which is that this would be feedback loop. At the end of it, we want to create a model that, in fact, potentially would be deployed onto an edge device. One thing to think about is that how many of these feedback loops can you do? So this might be a question is maybe as 2A is how many iterations can you get to, right? So if for your final project, this is what I've seen students that have been really good final projects is how many of these runs are you doing? If you just did one, you're probably not going to have that great of a final project because you spent all of your time on, let's say, TensorFlow or something like that. And if you're spending all of your time outside of the feedback loop, then it's not going to be as powerful if you're able to just quickly go through. So we had just talked about that there's all these other problems that happen with this thing is irritating when you share this way. All these other problems that happen with computer vision, and one of them is, we know that the data could be a problem, right? So if you're not able to quickly, go through and test it out, look at it inside the AutoML interface. Okay, what's the bad data? So the data itself is kind of a mini feedback loop. Is the data bad? Is it good? Do you have enough data? And so if you're able to actually quickly go through and think about this, that's how I think you'll get the best final prediction. Is how many times can you go through this cycle and quickly come up with constant improvement? And there's a word for this. And the word for this, in fact, is called Kaizen, right? And this is really the premise. In Japanese, Kaizen means improvement, and this is the heart of the Japanese automobile industry and why they've been so successful, is that they're constantly improving every day, making a feedback loop. So just something to think about. This is what I think AutoML really does, is it allows you to focus on the business problem, use these high-level tools, and go through and find out where are your real problems. Is the problem with the data? If the data needs to be augmented, okay, great. Let's use some tool. Let's use Keras to do data augmentation, or let's use Image Magic and transform the images. Let's get more images. But how do you know unless you've put it through the feedback loop? Likewise, I guess on the flip side is if you spend all of your time training the model by writing the code yourself and you get one feedback loop, I don't think that's the best way to get to the solution, because there's an expression called garbage in is equal to garbage out, and so we'll say garbage in is equal to garbage out. And what that means is that first make sure that this thing is actually the right stuff, right? The right data, and are you addressing a problem that can actually be solved? Now, it doesn't mean that AutoML is the solution for everything. It could turn out that maybe it's too expensive, or you think you can do it better. But what I've seen, most of my experience, especially when you're dealing with people that are relatively new to computer vision, is that I've never seen the case where the AutoML, it does worse than the human. Typically, it's better. So that's, I think, the key takeaway is what's the problem I'm trying to solve? How quickly can I do it? How many iterations can I run? And then let me put it onto the device, do the prediction, and test it out. So like that whole feedback loop. And this I guess gets into why it's important to think about real world solutions when you're solving problems. Is that I guess what is the impact on humanity is another way of putting this. So how, like in fact, if you look at the United States in particular, this is a really good example of am I helping? I think if you look at scientifically the response to the coronavirus in the United States, that was not very good, right? And why is it that it wasn't very good? Is that this feedback loop was very slow, and that feedback loop is really the essence. Is what is the business problem that I'm trying to solve? So let's take COVID-19 for example. If I said what problem I want to detect COVID-19 in X-ray scans, right? So let's just say detect COVID-19 in X-ray scans. COVID-19, right? So if that's the thing I'm trying to solve, that's very different than me as a scientist saying, hey, I'm a scientist and I want to use TensorFlow because it's fun, right? Those are two different problems, right? These are right. They're very different problems. One is there's people dying. I want to help them, and I want to find out as quickly as possible. So why don't we just use the best tools? And this is where the feedback loop comes in. Is that things like again like AutoML, what's great about it is that I can actually with AutoML focus more quickly on the business problem and put that into the feedback loop. And so then every day I say, is the model better? Is the model better? And then this is really the thing that I'm trying to solve. And then eventually, let's say after 40 iterations, you could keep on putting more. You could put more data in here. You could augment the data. You could you could try it out by taking the model to an edge device and even giving it to a doctor, right? You could go to a doctor and say, hey, let's try this out. This is the whole feedback loop. And in my opinion, this is diametrically opposed to this approach, which is I want to use complex code. There's a place for that, like if you're writing research papers or something like that. But I think this is the core problem of one of the issues with the way the United States addressed the COVID-19 issue is that they don't have a sense of urgency, they don't have a feedback loop, and they're not going through and constantly doing daily improvement, right? And so I think that's why the United States in particular is one of the worst in the world actually at their response, is that they're not daily making improvements, and so I think that's why AutoML is an interesting tool, is that you can for a second put aside the scientific complexity of how much code you're writing and get right into the business aspects of things. And so the last thing I'll close with that I only have a little bit of time to talk about would be that also another open source version of AutoML is called Ludwig. And so if you're an advanced student and you want to really push yourself and try some other ways of doing AutoML that fit very well, right? Because this is a TensorFlow based framework, Ludwig. It originally came out of Uber. This might be another one, right? Is that you also could use a free open source version, and you could potentially exhaust all of the training in the cloud and not have a budget anymore. But then you could train this locally on your own machines, and then also do the same thing, because you can convert a TensorFlow model to TensorFlow Lite and then take that model and deploy it to an edge device. So there's another option that I haven't really seen students use yet, but it is actually a very powerful AutoML system in that you just put in the CSV file just like the AutoML from Google, and you put in the model definition right here, which is this data. And then it's the same thing. It's the exact same concept. Here's my image path. Here's the class with the label inside of it, and that will be the end solution. So I'm going to stop the share.